Hey there, Bruno, Monica, or Yannick, who I don't know who's going to be looking at this, but whoever it is. I came in earlier today to demonstrate this project, my final Physics 12 project, but there were a couple substitute teachers there, so I demonstrated to Yanni, who wrote a note, but I thought I should probably make a video of this too. I was originally going to make a video for this whole thing, and that was going to be the focus, but as I kept making this magnetic levitation train, it more and more became the actual project itself, and I'm hoping that this is enough for the Physics 12 project. If it's not and you want me to expand further on this, like say the concepts behind this, let me know, but I made both a magnetic levitation train, and I also made my own little microphone that I put into a mixer to amplify the signal, and with that I powered some LEDs that go around the magnetic levitation train, as you will see. I call it the rave train because I live in a communal house with a garage full of ravers, so we have a PA system there, and it's going to be the rave train that stays in the garage. So off we go. I'll show you to the magnetic levitation train, and yeah, I hope you enjoy. So, as you can see, we have the magnetic levitation train track right here. And if we flip this over, we will see that there is a microphone that I made with a Pringles cup and a magnet and a coil. As the vibration from the train goes back and forth, it vibrates the magnet and the coil, really, and actually the Pringles tube actually amplifies it a bit, and then with the coil vibrating around the magnet, it creates electromagnetic induction. It induces a current in the coil that is with a voltage that is similar in terms of oscillations to the sound waves that it produces, and that is then being sent with these wires that I soldered to the mixer. And I don't know if any of you know much about audio, but essentially I made the microphone, I soldered with an XLR cord, and then there's two sets of lights on this train track. There's the red lights, this is the output from the mixer, or the input for the lights, and the input for the red lights. Sorry, blue lights, red lights on the train track. Now here's the train tracks. I glued on magnets, and you can see the north side of the magnets are labeled there. And I had made a couple prototypes. One was an almost circular track, and I was hoping to get a train going around and around, but that was actually a lot more difficult, because the thing that I learned, well, I could foresee, but really learned, was that if there is even a slight difference in magnetism between the train tracks, between the two train tracks and the train itself, between one side and another, the train it'll create kind of a snowball effect where there's a little bit of repulsion that pushes the other side around, and then the other side starts attracting the other, and it just snowballs into the train flipping. And I assume, or I guess, that when it comes to professional maglev trains, that is probably one of the most difficult things to engineer, because if there is any kind of difference in magnetism, you don't want a whole train flipping around. So this is the train itself. Meet Lenny. I'll focus him. Honestly, Lenny just wants a hug, and he's a very nice guy, and he's the conductor of this train. Now we're going to turn the mixer on, and I'm going to turn this light off. Let's see if this still... Now you're going to see the true effects of the rave train.